Hey guys, welcome to my channel. I'm LEETCODE, and today, guys, we have an amazing problem for you guys called construct binary tree from preorder and inorder traversal, right? So very good stuff, right? It says given two integer arrays, right? Preorder and inorder, right? Where the preorder is the preorder traversal, that makes sense, and the inorder is the inorder traversal of the same tree, guys, right? Of the same tree. So he says to construct and return the binary tree, right? So you can see that as input, we get two preorders and inorders, right? And our job, right, is to construct it based on those two information that we're given, right? So the preorder is the preorder of the binary tree, right? And the inorder is the inorder of that same binary tree, right? So it's very important to keep that in mind. So you can see that the constructed binary tree fits both, I'm saying, this preorder and the inorder that was given, right? We see if we do the inorder, right? We know what the inorder is, right? Inorder is obviously the left, the root, and then the right, and then the preorder is the root, and then the left and the right, right? Yeah, so let's just make sure we capture those kind of things so that we can refer to it, right? As we're going this. So the preorder, right? It's going to be the root, left, and the right. The inorder is going to be what, guys? Left, root, and then the right. Okay. So we get this in mind to refer so you guys can see what I'm talking about, right? So let's do a quick pre-order. Right? The pre-order will be 3, 9, in the reverse, right? And then 20, 15, and 7, right? Which is exactly what they have here, right? And the in order would be, since it is left root right, right? It will be the left first 9, the root 3, right? And then the left, right? 15, right? 20 and 7, right? So we see how it's going. So it's both of those matches the data. So this is perfectly fine, right? So this is exactly what we need to do. We need to write an algorithm, right? It's gonna take in those two information, right, that we're given and somehow construct the binary tree, right? The original binary tree that they get this information from, right? So we need to make sure we do that, guys. So how do we do that, right? How do we use those two things as I'm saying as so they can help us in a way, right? So let me think about it a little bit. So how can we do this? So do we use the pre-order? Do we use the in-order? I'm thinking that we need to use both, right? Somehow to kind of help us in constructing that because we need to take both into account, right? Okay, so how we can start off by, let's say, let's say we start off with 3, right? 3 is the root node, right? Okay, so how do we know to get 3? Okay, we see 3 right there. So the pre-order is going to give us the nodes no, root first and then left and right, right? Maybe we can start off by using the pre-order, right? Using the pre-order to build the root, right? Okay, so we build 3, boom. All right, and then we could go into the next one to the left subtree, put 9, boom. And then we could put 20 on the left side of 9. Oh, that doesn't match, guys, right? So we can't just go ahead and use the pre-order, right? Alone, we have to take that into account, right? And especially if we only take the pre-order, right? How do we know where to put 20? Do we put it on the left side of 3? Like, right? This is where the in order things comes into play, guys, right? This is when in order plays comes into play because we need to know how big is the left side, right? So that we can restrict the bounds when we do the recursive calls, right? When we call in a left subtree, we should tell a left subtree that, the pre-order, the amount of elements that you have on the left subtree is at most 1, right? Because how are you going to do that, guys, right? How can we tell it, right? So what we're going to do, we're going to get the index, right? So after we build the root node, right, for that node, right? So we need to find its index on the in order, right? So why do we need to find that? We need to find that because, right, we need to know how many elements are on its left side, right? So that's kind of the thought process that I want to get into with you guys, right? So we see that it's on the left side. So we see how many elements on the left side. So we see there's only one element on the left side, right? So therefore, since there's only one element, right? So we're gonna restrict the bounds. Say, yo, your bounds for my left subtree should be up to this one, right? As you're building your tree, right? So this is the only bounds that you have, right? So nothing beyond this you should not touch anything beyond this, right? So this is how we're gonna restrict those bounds and the recursive calls as we're building the tree, right? So we let it know. So that's how when we recurse on the right subtree, right? we calculate that, right? We get the length. We get the length of the left subtree, so the length is 1, right? So, right, because we're gonna have the index to the first one. So we get the so we take care of the whole left subtree, right? Which is only there's only 9 in that left subtree, right? And then we do the index of the root node plus the length of the left subtree, right? Plus 1. And then that will give us the bounds that we need, right? Which is on the right side. So this is where how 3 is gonna let the right side know, oh, this is where your bound starts, guys, right? So that's how it's going to know where to put 20 at, right? And where to do that, right? So make sure you guys understand that part. It's the most important part, right? To whatever index it is, right? I'm saying it adds the size of its left subtree, and it does plus 1 so that it could let the right subtree know this is where your bound start. And 20 is gonna do the exact same thing, right? It's gonna get when it goes on the right side here, right? It's going to uh pretty much get its index plus so that its index, right, plus the length of its left subtree, which is what, guys, right? The length is left subtree is only a size 1 because 15 is only known on the left side, right? And then that's how 7 is gonna know where to put itself, right? So this is kind of how it works, right? So let me do example. So when we get to 20, right? Uh 3 is gonna also pass in the bounds for the Inorder traversal as well, right? That's the other thing to account. It's also gonna pass in the Inorder index, which will be right. It's gonna be like, all right, cool. So everything on my left side, right? So on my left side, on my right side, I mean, you have 15, 20, and 7, right? So this is the bounds that it passes to the right boundary, right? So now, since 20 is the node, right? That since we're using the preorder to build the root, we add 20 and we find the index of 20, right? And since so now it builds its left and then it builds its right as well, right? It's how it does it, guys, right? So hopefully you guys will be able to understand and see how those two pieces of information are going to be useful, right? The in-order, the pre-order is going to help us in having access to what I'm saying. We're going to use the pre-order to build the root node, right? And then we're going to recurse on the left side by updating the boundaries. We're also going to pass it on to our right side as well to update the boundary, right? So hopefully the thought process was good. Let's quickly go ahead, guys, with the so to make it kind of efficient, right, we're going to use a hash map to find the index of the pre-order root node that we're building, right? Because if not for that, right, we would need to loop through the array, right, to find the index of that node, right? So we want to do it all one time, right? That's why we're going to do some pre-processing, right? And add the stuff to the hash map, right? So we're going to quickly do that real quick, guys, right? So let's do a map. So it's going to be integer to integer, right? Map. And then we're gonna do map, new hash map. I can memory for it. Yeah. What's next? So we're gonna do int I go to 0. So we're just looping through the array, the end of the array, right? I plus, right? And then we do map that put the nums. No, I'm tripping. In order I. Also pass in I as a parameter, right? Then we're gonna pretty much build the tree helper. So we're gonna pass in the pre-order, the in order, the bounds. So now we got passing the bounds, like you said, right? So we can restrict the space that they're considering, right? And when we're doing the recursive calls, right? Which is very, very important, right? So we're gonna do the pre-order first. And we're gonna do the same thing for the start, right? So it's gonna be in order that then -1. Okay. It should be -1 as well, right? So just quickly do the parameters. So private tree node, because we want a tree node how to turn, right? Helper, right? In order. So what's next, guys? We're gonna need to have it start. So we need to the start. So we're gonna pre-start, right? make sure that we stay consistent, and pre-end, and start, and end, right? Now we have those boundaries. So now we're gonna know if we get to, there's no more node to process by when we get when the pre starts greater than the pre-end, right? So this is not no bueno, or when the end start is greater than the end, right? So if that's the case, return null, please, right? Simple as that. What's next for us, right? We're going to need now. So now I told you guys, right? Tree node, root. We're gonna start building the root node. Let's go to new tree node, and we're gonna pass in, guys. We're gonna use the preorder to. So when we first start off, right, we use the root node, right? So we have access to it with the pre-start. Pre-start is gonna give us access to the root node every time, right? And we're gonna update the pre-start and all the recursive calls, right? Okay, so after you do that, you're almost good. So now we're gonna try and say, all right, cool. Now do my left side now, right? Preorder, Inorder. So now this is where things are gonna get very, very interesting. I'll just copy this real quick. To do the same thing for the right, as we're gonna update the bounds. And after we do that, we're gonna also have to return the root, right? Something. So how do we update the bounds, right? That's the important part, right? So now for pre-start, right? Pre-start should definitely, so how do I do the next element to go into, right? For the left side, right? I know that by just doing pre-start +1, right? There's no magic stuff that I need to worry about, right? Pre-start +1, which is whatever whatever I'm on right now, right? +1, right? To go into the next element, right? Very important. So now what's next, right? So how do we update the pre-end, right? The pre-end needs to be updated, right? So it knows how many elements to process on the left side for in the preorder, right? You know, it shouldn't touch any element right there, right? We want to make sure that that's very, very important, guys, right? Very, very important. So it's for it to know that's how many elements it shouldn't touch, right? So we're gonna update it by doing, right? So how do we let it know, right? We're gonna do, okay, how do I know how many elements on my left side, right? We could get that information, like I told you guys, on the left side. So we know there's only one element, right? So how can it know that? So it's gonna know that by doing the in order of the root node, right? The index of it, right? And the array minus, right? The space that was considering initially. So the pre-start, right? So initially it's 0. So we do 1 minus 0 to know how many elements on my left side. You see why we're doing this, right? Because how do we find how many elements on the left side, right? Obviously it's going to be from the index minus the starting index, right? That's what we're doing, guys, right? Make sure you guys understand that part. So so how it's going to be, so the pre-start, so we're going to be pre-start minus, right, map that get, right, get that number, right? So preorder, pre-start, right, get that number, right? So it'll be pre-start, not minus, plus, but that get number minus, right, the end start, right? Okay, and after we do that, we update the bounds. So the end start should stay the same, right? And the the end now should be updated as well, which will be what, guys? So I don't know why I did 0, 4. It should be end start. Stays the same, unchanged, right? And then for the end, right? Now the end boundary should be so this the kind so the end boundary, right? Since we did 3, right? The end boundary should be, yes, should be map that get that number, right? Get that number, right? And get its index -1, right? So we're almost there, right? So so now we've taken care of that first one, right? So how do we take care of the for the right side, right? So the right side in order, right? So we're gonna, so the pre-start is going to be what, guys? Pre is going to be whatever the pre-start is, right? So we need to get the actual index of the starting point, right? So the starting point for it should be, so how can know the numbers on the right side, right? It's going to be, I told you guys, the pre-start plus the length of the left subtree, right? So this is exactly what we're doing. So pre-start plus the length of my left subtree. So we get the length of my left subtree by doing what? My that get, right? So it's pretty much the same thing right there, minus the end start. It's exactly the same, guys, right? So pre-start plus the length of the left subtree, right? And we do +1, guys. So make sure that we account for that node, right? All right, so that we know that, we could, so it knows that to start from, like, not right here, but, +1 from that, right? All right. So after we do that, we update the pre-start so we know where to start on the pre-order, right? And now the pre-end stays the same, right? And so our end start will be what? That's pretty easy to get, right? So we do map that get, right? We just get the information from the in order, right? So we just do map that get pre-order, pre-start, whatever that is, +1. Okay, +1. So that we take another end start, and our end stays the same, should be, right? It looks pretty decent so far. Let's press run code. Okay, looks pretty good. Looks like we passed the small test case. Let's see, press submit. Awesome, guys. We were able to pass all the test cases, guys. So let me know, guys, if you guys found value in this kind of video, guys. Let me know some feedback if you guys really understood what I was trying to really show you guys, right? So, yet again, if you guys are new here, make sure to subscribe and like this video. You know what I'm saying, and yeah, let me know any kind of question you guys want me to do. I'll try to do it. All right. So I want to thank you guys for watching, and I'll see you guys in the next one.